Hey guys, welcome back. In the last lesson, we talked about an algorithm to rank pages using backlinks. In this lesson, we are going to look at the page terms from Wikipedia, which is going to be our dataset, but that is not the interesting part. We are going to write a custom input format and a custom pig load function, and that is going to be the exciting part of this lesson. So let's get started. What do we need to rank pages? We need a collection of pages and URL references between pages within the collection of pages, correct? But where we can find such a dataset? Lucky for us, Wikipedia offers a feature where you can go in and export collection of pages. Actually, it's very simple. Go to this web page. The URL for this page is included in the lesson notes. In the text box right here, type in the category of the pages you would like to download. For example, here is the Wikipedia page for Apache Software Foundation. I'm going to get all the pages under this category, Apache Software Foundation. So simply copy this text right here. This is the title of this page in Wikipedia. And this is the high-level category. Paste the page you just copied and click Add. This will add all the associated pages under the category. We are only interested in the current version and not the full history. So I've checked the checkbox for that option here and click Export. So this gives us an XML file. So let's open this file in Notepad. As I was saying, this is an XML file. And that is right, not a bunch of HTML files, but one XML file. That is an important reason why we chose this project in our course. The main objective of this course is to get you used to formats that are not straightforward, so you're well equipped with knowledge that you need to solve problems in real world. And we'll do exactly that in this lesson. Dealing with XML file brings in new challenges, and we'll see how to solve them. Keep in mind that this file does not have the HTML text for the pages. This file will have the metadata information about the pages in XML format. This XML file clearly has a lot of information, but what do we really need to calculate page ranking? We need to extract a page, and the list of links or URL references from the page to the other pages. So in this dataset, we need to know how to identify a page and how to find the URL references going out from each page. The information in the XML looks like a lot, but it is easy to identify a page actually. Just simply look for the page tag. And when you see a page tag like here, that identifies the start of the page. And when you see an ending page tag, that denotes the end of the page. So this whole block of text is a page for Apache Ant. Let's look at the page for Apache Ant. It has a page tag and that identifies it is a page. So we have identified a page. Now how do we identify the URLs? Let's go to Apache Ant's actual Wikipedia page. As you can see, there are several URLs pointing to other pages, right? Let's pick cross-platform for instance. This is a URL, and let's try to find this URL in the XML file. So copy this. Just search for cross-platform. There you go. Here is a URL going out to the cross-platform page. Similarly, you can find the other URLs as well. For example, if you take Apache license and this is a URL, you can find this URL right here. And if you want to pick another URL, for example, build tool, you can also find the URL right here. Do you see a pattern to spot the URLs now? Whenever you see a double square brackets, that indicate a URL. How about let's look for this URL Maven in our XML file. So let's search for Maven. There you go. It starts with double square brackets. So we know how to look up for pages in our dataset and also how to look up for URL references from each page. Now comes the real challenge. How can we load this dataset in Pig? And how can we extract just the information we need from the dataset? That is the page and the URL references are links from each page. Let's go over this problem and see what do we need here. Let's refresh our memory on how we loaded the stocks dataset for instance. We used the load instruction and used pick storage function to load the stocks dataset. Remember, stocks dataset is a text file with each line in the file being a record. And pick storage is a load function that parses a line of text input and extract the columns from the line of text and map it to the columns using a character delimiter. So here, it takes the first column and map it to exchange, second column to symbol, and so on. Now let's think about what we need from our Wikipedia dataset to perform page ranking. For each page in the dataset, we would need the page name and the list of URLs from that page, correct? And we know how to identify both information manually. Do you think we can use pick storage function to extract the information we need? No, because pick storage can only process a line of text with a column delimiter, whereas in our dataset, each page could go over multiple lines. As you can see right here, this is one page for Apache Ant, and it spans across multiple lines. And we need to look for specific keyword, that is the page tag, to extract the page name, and inside the page we need to look for double square brackets to extract the list of URLs. So we need to create a custom load function. Let's call it page rank load function to get the job done. This load function will take in a page and extract the page title and its list of URLs. So far clear? Okay. The pick storage function uses an implementation of text input format named pick text input format behind the scenes to read the dataset. And the text input format implementation will use line record reader to extract one line of text at a time from the file and pass it on to the pick storage function. Do you think we can use the text input format and line record reader for our XML dataset to extract one page of text at a time? No, because in our XML dataset, each logical record is not a line of text. Each record in our dataset can span over multiple lines. We have to look for the start page tag and the end page tag and extract all the text from the start page tag to the end page tag. And that is one logical record for us. Make sense? So, we need to come up with our own implementation of input format and record reader. We will call it XML input format and XML record reader. So our XML input format will read our XML dataset from Wikipedia, and the XML record reader will extract one page from XML dataset at a time and pass it on to the page rank load function. The page rank load function actually takes in the page, and from the page it extracts two key pieces of information. One is the page title, and the second piece of information is the list of URL references from that page going out to other pages. Now it is time to understand how to write a custom input format, that is the XML input format. I have a project here called PageRankPig, and it has two files, PageRankLoad.java and XML input format.java. And in the pom.xml file, I have included a list of dependencies that is needed for this project. Writing an input format from scratch is a lot of work. So the best and easiest way is to extend an already available input format and override just the methods that is relevant to what we are trying to do here. Let me explain. If you think about it, the XML is a text file whose contents are in XML format. And we have text input format which comes out of the box from Hadoop, which perfectly deals with text files. What we don't like in the text input format is its record reader implementation, which is line record reader, which returns a line of text as a logical record. This is not what we wanted, because in our dataset, a logical record is a page which can span across multiple lines. So all we have to do is extend the text input format in our XML input format class and override the record reader implementation to use our XML record reader implementation. Let's now look at the code. As mentioned, we are extending the text input format in our XML input format. And the next important thing we will do in XML input format is to override the create record reader method, which will create the XML record reader, like right here. The create record reader will have access to the input split, which will give access to the dataset. and we'll pass that in to the XML record reader constructor so that the XML record reader will have access to the data and extract the page from the dataset. Now let's look at the details of XML record reader. Create the XML record reader by extending record reader. Now in the constructor of XML record reader, we have access to the input split. Input split gives us the access to the dataset. Let's look at the constructor. We know each page starts with a page tag and ends with a closing page tag. So we set them in variables which we will use later. Next, we set the starting and ending position of the split. We position the FS data input stream to the start of the split. Next important function is the next key value function because it will be used by the big load function that we will create next to get the record from the dataset. A record is nothing but a page from the XML file. So the next key value function will return one page at a time. This method will find and set the values for key and value from the input split. Here is where we have to give our logic to scan the input split and return each page as a record by setting the key, which is nothing but the position of the page in the file. And we don't have a need for this, but we'll set it anyway. The value property will have the actual contents or the text of the page. We will first go to the start of the page tag. We'll use the read until match function to look for a possible match for the start of the page in the split. If there is a match, the FS data input stream will be positioned to the start of the page and the function will return true. If no match is found, the function will return false, meaning there are no pages in the split. Once there is a match, we'll look for the page closing tag and we'll write all the contents between the start and the end tag into the buffer. And we'll again use the read until match function for that. You can notice that this function has two parameters. And for the start tag, it is set to false, and for the end tag, it is set to true when you call this function. The second parameter in this function actually dictates whether the search for the tag can go beyond the end of the input split or not. For the start tag, we will only search the current input split, but our search for the end tag can go beyond the current input split. Why? Because a page can start in the current split and can span across more than one split. We don't have to write additional code to span across the splits. It will be automatically taken care by the FS data input stream class. So once we find a match for the end closing page tag, we'll write all the buffer contents between the start and the end tag into the value, forming a perfect key value for the record. That is it. The XML input format is ready, which has a good record reader implementation, that is XML record reader, which we can use to get one page at a time by calling the next key value function, which is defined inside the XML record reader implementation. Now we have a good solution to get pages from the dataset. The next step is to extract the needed information from the page to calculate the page rank. From a page, we need the title of the page and all the URL references that the page has to other pages inside the dataset. That is exactly what this page rank load function will do. So the page rank load function will use the XML input format and XML record reader to get the page contents and will extract the page title and URL references from the page. But not just that. Once it has the information, it should make the information available to be used in Pig in form of a tuple. Let's now look at the code. This page rank load function will return a tuple with two columns for each page. A tuple is nothing but a row, correct? So the first column is the page title and the second column is the list of pages that are being referenced by the page. The load function is not complex. I'll walk you through step by step. The very first thing is we need to make the class a Pig load function by extending the load function. The next three methods will help us get the records from the dataset. In our cases, it is the pages from the dataset. Ultimately, we should be able to call the get next key value in the XML record reader implementation inside the XML input format. The location string that you provide in the load instruction will be passed on to the setLocation method, and the location will be set to the file input format. The next method is very important and it tells Pig which input format to use. In this case, we will return the XML input format that we created. Finally, in the third prepare to read method, we can get access to the reader. Since we have already specified that we will be using the XML input format in the get input format method, the prepare to read method will give us a reference to the XML record reader. Next, let's look at the get next method. This is where the magic happens. This method returns a tuple with two columns. Column 1 is the page title and column 2 with the list of links. Since a page might have a lot of links, we need to set multiple values in column 2. So how we can set multiple values in column 2? Any guesses? Let's make the column 2 to be a bag. Since a bag is a collection of tuples, we can add each link to be a tuple inside the bag. In the end, the bag element will have all the links. The getNext method will be called for every record or page returned by the XML record reader from your XML input format. Now use the next key value function to proceed to the next key value and get the current value using the getCurrentValue function. The value here, which is nothing but the contents of the page. From this value, we need to get the page title and the list of links going out from this page. So we will use some logic here to extract the title first, which will set to the page title variable, and then go ahead and extract the page content and set it to the page content variable. And as I was saying, here is a tuple with two columns. So we'll set the page title as the first column in our tuple. The next, we need to find the list of URL references from this page pointing out to other pages. What we will do is we'll extract each link, we'll create a tuple, and we'll add the tuple into a bag. And then finally, we'll set that bag as the second column in our tuple. Remember from the previous lesson that we saw that the URLs are always surrounded by double square brackets. With that information, we are going to use the regex pattern matcher to get all the links. Now for each link that we find in our page, we need to extract the title of the page that the link is pointing to. So we'll use a helper function getPage to do exactly that. So this function will take in the link and it will make few checks to make sure that the link is actually good. If the link is not good, it will return null. But when the link is good, it will return the actual title of the page that the link is pointing to. Since a page could have many URL references, we'll create a bag and we'll set the page title of all the URL references in the bag. Bag is nothing but a collection of tuples, so you need to create a tuple for each link and add it to the bag. Once we have information from all the links added to the bag, we have to add the bag to the second column in the tuple. That is what we are doing here. Finally, you return tuple. That is it. Our load function is ready to use and can be used just like the pick storage function in the load instruction, which we'll see in the next lesson. I know that was a lot to take in, but when you look over the code once, it will all make perfect sense. So let me summarize. We first created a custom input format named XML input format. Inside the XML input format, we implemented a custom record reader named XML record reader to get the records from the input split. Each record in our case is a page which can span across multiple lines. Then we created a custom load function to return the page title and the list of link references from each page. We used the XML input format in the load function, and in the getNext function, we returned a tuple with two columns. Column 1 as the page title and column 2 as bags with many link references from the page. In the next lesson, we will use this page rank load function to load the dataset and calculate the page rank, and we'll write a big script which does the page ranking. See you in the next lesson.